I'm Louis Bergeron, Senior Vice President at Govini. I joined Govini after a career in the Navy. In the Navy and today at Govini, we get to see firsthand the incredible work being done to build and modernize the Navy fleet. While I was also at sea and at the Pentagon, I got to see the real impact that of having a fleet with the right capabilities and right capacity to meet pressing demands were. Every day, your Navy is on patrol to deter adversaries, to project power when necessary, and to secure sea lanes, which are the bedrock of the global economy. Today's headlines out of the Red Sea and across the world demonstrate the role and the value that sea services play. The sailors and Marines serve on ships, submarines, and aircraft that are built by industry and sustained by sailors and industry partners. So, I'm very excited to introduce this next panel, Fleeting Up, Shipbuilding and Modernization. As the United States looks toward its pacing challenge, China's rapid naval modernization casts a tall shadow. China has invested significant resources in fielding new ships at a pace that eclipses the United States, as well as anti-access capabilities to keep the United States Navy at bay. Emboldened by this maritime force buildup, China has become increasingly aggressive in the South China Sea and beyond. To accelerate the United States' own pace of shipbuilding, data and technology are key to enable the production, the readiness, and the fleet modernization needed to counter China's growing maritime influence. So please welcome our panelists who will share their own visions of how the Navy meets these challenges head on. Rear Admiral Fred Pyle, who serves as Director, Surface Warfare Division, N96 in the Office of the Chief of Naval Operations. Captain Matt Culp, Senior Advisor, Office of the Chief of Naval Operations and CNO's Technical Advisor. Mr. Bruno Pontes Soares Rocha, who is the Chief Operating Officer of Gecko Robotics, and your panel moderator, Mr. Bryan Clark, who is Senior Fellow at the Hudson Institute. Welcome all and enjoy the panel.
Thank you, everybody, for the opportunity for us to get together today. Thank you, Admiral and Matt and Bruno, for being with us today. Let's get right into the conversation about shipbuilding and naval modernization and how data analytics and AI kind of play into it. It seems like a topic that doesn't lend itself to necessarily these high-tech modern solutions, but obviously there's a lot of places where we can employ those technologies to improve both our shipbuilding and our ability to field a fleet that's able to address the threats that are emerging right now and obviously are going to come in the future. So to start with, Admiral Pyle, so I wanted to ask kind of each of the guests, what they see as some of the biggest potential in data analytics and AI in their portfolio. And so in the area of surface warfare, where do you see the most potential coming out of applications of these technologies, which are really cutting edge? We just heard a whole panel talking about unmanned systems and decision support and those things. Where does this come into surface warfare and then kind of our traditional Navy more generally?
Thanks, Brian. And good afternoon, everybody. Fred Pyle. Second year I've been here. Last year I was an attendee, and this year it's great to be here on the stage with you and my fellow panel members, and I thank the leadership of this Software and Data Summit for the opportunity to do this, so thank you. First, I need to provide a disclaimer that while I don't have a call sign, I think it should be imposter, because when it comes to data and software development, I am not a subject matter expert. I'm a huge consumer of it, and I can speak to that, but where we are in the surface force is the CNO has given us guidance, our CNO, Admiral Lisa Franchetti, that everything we do, we'll look at it through a warfighting lens. And that starts with, if we're gonna identify a capability that needs to go into the fleet, it's threat informed. We collect facts, and then it's supported by data, and it's supported by analytic rigor before you even get to the table and have a conversation about resourcing that capability. We work hard to make sure we have that analytic rigor. We leverage artificial intelligence, machine learning, and software development to get after supporting those arguments. There's a couple key areas that we as warfighters value when it comes to artificial intelligence. First, faster and more accurate decision making. Our operators need to sift through a lot of data, whether that's satellite data, sensor data, radar, or information from an autonomous system. AI provides a means to expedite that process for the operators. Enhancing situational awareness, so understanding where the threat is, what the threat's doing. Mission planning, what we're going to do to lay down blue assets, where red is at, and then how we're going to go through weapon sensor pairing. And then, of course, cybersecurity. AI can assist us in cybersecurity to make sure we're monitoring networks, patterns and behaviors, and alert operators if there's an intrusion. And then finally, the human-AI collaboration, where AI can support the operator on what they're doing. So we use data from both a diagnostic and as a predictive tool to get after what we're trying to change. I believe we're at an inflection point in the Navy. We are moving out on this effort. We can always move faster, but I think we're moving in a good direction. Thanks, Bryan.
Thanks, Admiral. And we'll dig into some of those other areas as we go through the conversation today. So turning to Matt. So Matt Culp, Senior Advisor to the CNO. You're also helping out with the stand-up of the Disruptive Capabilities Office, which is inherently designed to bring in some of these emerging technologies, try to make them useful for naval operations. Kind of where do you see AI, data analytics, how do they come into play here? And how does this possibly shift the way that the Navy approaches new technology, moving from its traditional role of developing it to something else?
Sure. Thanks, Bryan. Great to be here, standing in for Michael Stewart. The snowstorm wreaked havoc on a lot of people's schedules at the Pentagon, so you get me instead. So I think as we look at Disruptive Capabilities Office, it's really focused on the problem of, hey, how do we move beyond just innovation to deliver prototypes? And how do you take those prototypes and really deliver to the warfighter at scale solutions that matter to them? And so when we think about disruptive technologies, I think between AI and data analytics, where will that not play an important role? So I think the most important question we need to ask and be clear-eyed with ourselves and clearly be able to articulate is what's the problem we want to solve with those tools. Because it's easy to say, oh yeah, we'll just sprinkle some AI on this and it's going to be great. Imagine a world of artificial intelligence, but unless you can clearly articulate, hey, this is what we're trying to do, I think it's going to be tough for us to really get that capability to the warfighter that they need. So when we think about the strategic imperative for this, the last panel talked a lot about the challenge of deterring China, which ultimately would be underpinned by our ability to defeat China in conflict. And so, God forbid we went to war, it would be this total war in the Pacific. And the historical analogy for that is, of course, World War II. Great news is we won World War II, back-to-back World War champions, USA. But if you look at that historical analogy, are we the United States or are we Japan in that situation? And I think we recognize we have a vast shipbuilding deficit against China. Depending on the numbers you believe, 25 or 30 to 1, China could outbuild us if it went to that total war. So we really need to think differently. And so in a future conflict, we don't want this to be an industrial-based fight versus an industrial-based fight. We need to leverage the innovation sector. We need to leverage Silicon Valley, Boston, Austin, and get new entrant defense tech to help the DoD solve these problems. And we need to change the way we think as DoD, instead of just thinking well, I have this problem, so I need this thing. Who can give me this thing? And I think we can have better conversations with software and industry, particularly when we look at AI and data analytics, to say, hey, look, I have this problem. Commercial sector, what are all the different ways that you could think about how we could solve this problem using the tool sets that you might have to offer? And I think we'd come up with some pretty incredible solutions with AI.
So talking about some of those solutions, Bruno, you lead as the Chief Operating Officer Gecko Robotics, which is a company that does this kind of AI and data analytics for the Navy among their customers. So where do you see the potential of these technologies being in advancing shipbuilding, advancing naval modernization?
Yes, thanks, Bryan. So what we do at Gecko, and I think what we're starting to see tremendous improvements on, and there's still a lot more to be had, is by combining, it's not only AI, it's only good as the data it consumes. So by merging AI solutions with robotics data acquisition. So at Gecko we have in-house robotics platforms that collect data at a higher fidelity, at a higher efficiency than what's out there. And they feed our software platform, Cantilever, which is AI-backed. And we do this for the Navy right now for two main goals. One is battle readiness. Ships are coming into dry dock, and they need to create repair plans. They need to be scanned. You need to know where the defects are, what the problems are. Then you have to get that, put it against the budget, put it against the timeline, create a repair plan. So doing that in an automated fashion gets the ship to the ocean faster, increases battle readiness, which is great because you're not just talking about brute forcing your capabilities, you're talking about increasing efficiency. Similarly, we're working with construction as well. We're working, it's public knowledge, we're working in the Columbia class sub program. But the problem is you have parts from hundreds of suppliers that needs to fit together. And there's a lengthy process to even make sure that every part is true specifications that they're actually going to fit. By using robotics and AI, you can speed up that process. And it's a technology that it's extremely useful. We're using it to the Air Force as well in the missile silos, the ICBM. So being applied at 2 out of 3 of our nuclear legs right now. So and in industry as well. So I think there's a lot there. We're starting to see orders of magnitude in gains in efficiency, but it's just the tip of the iceberg.
Right. Yeah, so Bruno brings up readiness, and last week at Surface Navy Association, we talked a lot about the demands on the fleet. The success that the fleet has had recently in the Red Sea and protecting shipping and carrying out strikes against Houthi sites. But keeping that fleet out there at the tempo that it's operating is going to be tough. So Admiral, how are we looking to use these new technologies to improve our ability to keep the fleet ready? Because when you talk to the ship repair companies and the folks that work in that industry, they say it's really hard to get things scheduled and planned and executed on time when you're dealing with the real world also events and driving the schedule. So how do you try to work through all that using these technologies?
Thanks, Bryan. And to follow on what Bruno mentioned, this is an area, ship maintenance is an area ripe for data analytics. We have 73 destroyers in the fleet today. We've been building this program for 40 years. We've been modernizing these ships for over 3 decades. So there's a ton of data out there. The question is, do we have it in the right format so we can actually leverage that data? And that's something we're working on. Things we've found is and when we build a work package for a ship going into an availability, a Chief of Naval Operations availability, if we can lock that work package 120 days out, that gives the contractor the opportunity to make sure they have labor, that they have parts, that when the ship arrives in yard, they're ready to go to work and they're not still working through getting set up to commence work on day one. Part of that survey and getting to that A-120 award is ship checks. In the past, it has been largely a manual process. We're working to automate that process so we can leverage that data from 4+ decades and get to a more predictive building the work package.
Right.
Also, it comes into players on the field. CNO has talked about this since her confirmation hearing in October, and what players on the field means is reducing the number of days of delayed maintenance when a ship does not get out of the availability on time. Yeah. That's critical. Another piece, we're working closely with all of our industry partners in those private yards to help them come through green labor issues. Folks that have been on board less than 5 years and may not have the experience of their predecessors, working through supply chain, tool flow, just the processes in the yard to make sure that when a worker arrives, they have the parts, they have the tools, and they have the task to get after it. And then the last piece is growth work. So, to oversimplify this, you have your car, you're going to go in and get a state inspection and an oil change. And you have an expectation of time and money that's going to take. And maybe it's an older car and you find out that the transmission is having issues and you have a timing belt issue. That's growth work in the shipbuilding industry. Yeah. And that's an area where we struggle to make sure we don't have growth work. So definitizing that work package, leveraging data to make sure we understand the condition of the ship as it goes in, will definitely help us to get ships out of maintenance on time.
And I assume predictive analytics can help you to figure out what's the likelihood that that growth will happen, right? Based on the preceding ships of that class that have gone through and we've had similar experiences.
You bet.
And is that the kind of work that, Bruno, you guys do when you're working with the Navy on these ship availabilities?
Yeah, and I think, absolutely, and I think it's even more powerful when you do it over time. So the key here is to standardize and digitize data. Data already exists, it always has existed,
right.
But quality of data is extremely important. Right. So when you standardize and digitize it, you scan a ship that's coming into dry dock, and then 3 years later, or however many months later, when the ship comes back, right. You are following on the same record. You have a time series, you have a differential analysis. You can say, you can detect the patterns of what is failing according to each environment. And then you can close the loop and feed that data back to the, not even the construction, I would say the design process, so that you can actually design better ships.
Yeah, and I think that, just to kind of hammer on that point, we're talking about, when you talk to people in the shipbuilding industry and also in the aviation industry, they talk about building digital models, digital twins of existing systems, but also digital models to allow them to do the designing of the process to construct the ship to make it as efficient as possible. So you're talking about, not just using that digital model to inform future availabilities or future maintenance work. You're talking about actually feeding that back to the people that are building the next version of that ship.
Exactly. Once you've done enough on the future side, you're gonna start feeding that back, because you're gonna start figuring out what is the most efficient way. You're gonna start figuring out the patterns of what fails when and why.
Right. Yeah. So then one last thing on the this area I wanted to talk about is shipbuilding. So shipbuilding is going to obviously come up here the next couple of months as we go into posture season. There's a bunch of hearings about the budget request, which will come out in probably March at this point. Mm-hmm. I'm sure that people on the Hill and a lot of people out in industry are going to be probably disappointed, and the Navy's not building as many ships as they want. Can we, leverage these technologies? Bruno talked a little bit about supply chain and how do we streamline or better understand the supply chain. Can we use data analytics to help us to improve the speed and the efficacy of our shipbuilding efforts?
Yes, in the design. So for the surface fleet, our next destroyer is called DDGX. That's currently scheduled to commence construction in FY32 for the 24 budget. FFG 62, the frigate Constellation class, is under construction up in Marinette, Wisconsin. And then the LUSV, the large unmanned surface vessel, which is an adjunct magazine, will begin later this decade. So absolutely we can leverage analytics and AI to improve the speed at which we work through design issues. We're leveraging previous classes of ships, so Oliver Hazard Perry class, Spruance class, cruisers, making sure we take the best of breed from the hull mechanical and electrical design to the combat systems, and we're applying that to those future classes of ships. With the shipbuilding piece, we're shifting to an evolutionary vice a revolutionary approach. What we've learned over the years is if you're going to make changes, it's good to pick between the propulsion plant or combat systems, but not both. So if you look at the approach on DDGX, we're taking the existing weapon system, SPY-6, Aegis Baseline 10, the electronic warfare suite from the Flight 3 destroyer that was just commissioned, and we're dropping that lock, stock, and barrel into the DDGX. Hull design and propulsion plant is going to be different. So that's where we're going to apply a significant amount of design work, AI, to make sure we mature that in a land-based test before actually taking it to sea.
Right. So let's talk a little bit about talking about kind of where we're going in the future now. So Matt, you were instrumental in the stand-up of this Disruptive Capabilities Office that recently was established by the SecNav. It's now up and running. What's its role in driving change in what the Navy has in the fleet? And how does it apply new technologies like AI-enabled algorithms and data analytics?
Sure. So Admiral Pyle brought up the CNO's focus A on warfighting and B kind of this focus on more players on the field. And so I think what's important as we think about the development of the hybrid fleet, and particularly in our conversations with the public and Congress, is it's not like an or. It's not like is it going to be manned platforms or unmanned platforms? It's an and. We need the platforms that we have, the aircraft carriers, the shores, the frigates. But what we can do is augment them and complement them with this hybrid fleet of unmanned systems. And so particularly when you look, I brought up the analogy of are we US or Japan? We can increase numbers rapidly, not by turning up to 11 the US shipbuilding industry. We're not going to be able to build the numbers that we need. But if we can scan across the American innovation ecosystem, I think we can find things that are on the shelf, dual use applicability for the Navy can adopt, and can rapidly drive up warfighting capability and get it to our warfighters quickly. And so that's really going to be the main focus of the DCO, is to, again, start with that idea of, hey, I'm not going to give you necessarily a requirement, I need this exact thing, but to communicate an operational problem that we're trying to solve. Take that problem and then scan across the innovation base, of course, scan across the Navy warfighting labs and the traditional defense industrial base, but also go out to the non-traditional innovation base and see what they have to offer. And then set up sandboxes or set up opportunities for us to have real collisions and say, hey, what's better? Let's iterate, let's get real feedback from the warfighter to see what actually works, what they can actually use, what we can adopt, and work it from there. And so where data analytics and AI fit in there is that certainly within the DoD, we become very enamored with the robots themselves. We think when we think about unmanned systems, like, oh, we need the system, we need the robot, we need the truck. But really, it's much more about the data. It's much more about the network. And about the decision making, the AI that goes on to it. And so, in some ways, I think we're a little constrained in our thinking, where broadly we think about hardware. I mean, they go, have this piece of hardware, and I'll make sure the software fits on top of it to make it work. But I think this new age that we're developing, that's probably the wrong mindset. It's actually the software first, and what's the hardware that we wrap around it to make sure it gets out to the warfighter.
And so, Matt, one thing that makes me think of is it sort of puts the DoD in the position of being a customer of technology rather than a driver of technology like it's used to have been. So as a customer, I guess, integration and applying AI and data architectures, that's the way that you pull together. That's the way you're a good customer, I guess. You bring in these new technologies and can pull them off the shelf and deliver them to somebody who can use them operationally. Is that kind of the mode that the DCO is pursuing?
Yeah, I think that's right. It's trying to give a forum for these, again, non-traditional defense tech entrants to speak with, to have an opportunity to experiment with the fleet, to iterate, and to prove, hey, what they have can make a difference. So make the Navy a better customer, not only to give a doorway for them to come in, but also a better customer in terms of, hey, we'll give real feedback on how this solves our problem and how it doesn't. Part of becoming a better customer, I think it's a cultural shift within the Navy that needs to be achieved to change the way we think. Again, move away from that sort of requirements-based thinking and be more broad-minded about thinking about a broader set of capabilities that can solve our problems. And then two, it's just kind of recognizing all the bureaucratic sort of hurdles that kind of happen inside the system that frustrate industry, and from senior leadership on down, finding ways that we can tackle those, knock those barriers down, to make working with DoD less of a frustrating experience.
Yes, well, we heard that from the last panel for sure. So Bruno, a question that brings up is, how do we assess this solution space, right? So if you've got an operational problem that a fleet commander is defined and that the DCO is going to try to come up with a solution to, there's not an infinite, but there's certainly a very large solution space out there that you might have to sort through. How can we instrument the environment in a way that helps to inform that decision space? How can we better understand what the solutions potentially are, and can we use digital models of those potential solutions and evaluate this in a virtual environment? Are there techniques we can use to sort of boil that down and to be something tractable, or is it just a massive plug fest and series of iterative exercises?
No, for sure there are, and I think there are operational techniques and there are like technology approaches as well. I think on the operational side, one thing that we've learned in industry, and I've spent a long time at Palantir as well, being forward deployed myself, right. It's just what I just said, being forward deployed, right. So having people embedded. Like I can't make anything better for the Navy if we don't have our people in the shipyards. So I think that's the first order of business here, having subject matter experts, having veterans that work with us, having people that understand the problems. Like we're saying, it should be centered around the problem, not requirement, so we need to understand the problem. On the technology side, the important thing is data. Like I said, I'm going to be slightly repetitive, but going a little bit deeper into the idea that AI is only as good as the data it consumes. The software, in the past couple of decades, software that consumes data has evolved tremendously, as we all know. Now that's creating a forcing function for the mechanisms that create that data, that scan that data to evolve in the same lockstep. So that's extremely important. And what's worse, there's like this a saying out there, AI is not an oracle, it's a mirror. So what's worse is that many AI techniques out there are consuming data that wasn't really created for that purpose. Right. So creating and investing in hardware mechanisms that will read the data, that will scan and create data for that purpose, so that data is certified organic, if I can put it that way. So it's created for the purpose of an AI-backed software that will allow you to build your ships more efficiently. That provides tremendous amount of gains, and we have seen those. Yeah.
That's a really good point, Bruno. So folks that work in this area sometimes talk about using synthetic data. So I'm going to go and run a bunch of models and do in a virtual environment, simulated exercises or simulated operations, and then I'll extract data out of that, and then I'll use that to train a model that's going to be used to do predictive analytics. And you're saying that that's probably you're to some degree you're sort of eating your own tail there. You're not necessarily getting organic, fresh data.
Yeah, it's tough. It's tough to imagine what the real world looks like inside a laboratory.
Right.
The physical world plays by much more complex rules than the rules we imagined up for the digital world, and we have to respect that. And the first step in respecting that is trying to understand it. It's an analogy to what I just said about being forward deployed, right? Like we have to do the same thing with data. And again, look, you do get tremendous returns. If you allow me an example, the work we've been doing with the Columbia class subs, you have the missile tubes, and for a single weld, you need to create a volumetric scan. Traditional techniques usually take 60 hours to create that volumetric scan. By using, robots and AI, we've reduced that to 4 hours. That's 6%, and that's our first result. So it's like that gives you a glimpse of how much more is out there for us to gain in efficiency.
So you could, so when it comes to the work that the DCO is doing, you could burn down this decision, this option space into something much more manageable.
Much more narrow, yeah.
Thanks to using better data from the field, as well as data that you generate in situ. So I'll talk a little bit more about that. So Admiral, this sort of takes us to some of the discussion about how are we going to modernize the fleet for the future. So we are talking about bringing in new technologies. We talked about the LUSV, DEG, et cetera. How do we decide what we do with the existing ships? Like, how can we use these data analytic techniques to better understand which of the current fleet we're going to keep and which of the current fleet we want to advance to be part of this future hybrid fleet that Matt talked about? Is there an approach that we're using to try and do that? The Navy has recently announced they're going to upgrade 4 ships to DDG 51 Flight 2, I guess, right?
The modernization.
So, modernization, yeah. So how does that decision-making process work?
So just to follow up on Matt's point about the, I would say the parallel effort between DCO and PPVE, and the previous panel made this point as well. It really has to be both.
Yeah.
There is the freight train engine that is PPV that's going to allow us to buy us the big stuff. But if we're going to deliver a capability within this decisive decade, DCO is the means by which we're going to do that. To your point on the fleet we have versus the future fleet, the fleet we have a significant modernization plan for our in-service DDGs. We're going to take 25 of the Flight 2 Alphas. So these are the ships somewhere mid-life. It's a 35-year ship. So at mid-life, we bring it in and we give it the latest technology of SPY-6, which is a phenomenal radar. We update the Aegis-based line, and then we put on some pretty sweet electronic kit that gives it game for a high-end fight in the South China Sea. The way we validate that capability is through a process called TD-NIF. It's called Terminal Defense Nav Plan Implementation Framework. It's the process by which we identify a capability that we think fills a gap. We take that capability and go off to an institution like Johns Hopkins or MIT Lincoln Lab, and we do the analytic rigor at a fully informed level. And if it fills the gap, then the next thing we want to do is take it to sea and test it as quickly as possible. And it is changing our behavior on the way we resource. It's more capabilities-based, platform-based, which I think is goodness. But it is changing the behavior on how we get after those capabilities. We're applying that same approach to future capabilities, such as directed energy, and how we can move terminal defense capability out of our vertical launch system and free up that space for offensive long-range fires, which is what we value. Right. So those are some examples of how we're applying that to modernization.
When you think about what to modernize and how, do you think of it in that system of systems context, where we're looking at, well, what else is going to be out there with the DDG? So if there's going to be an LUSV with it, or if there's going to be MUSVs or other unmanned vehicles with it, they can pick up, you essentially can decompose some of the functions of that DDG into those other platforms and relieve it of having to do everything at the same capacity internal to the skin of the ship. So does that part of the decision-making process in terms of what do you upgrade and how?
It is. So one of the examples to get after that problem you defined is integrated combat systems. So if you look at the 150 ships that make up our combatant fleet, surface fleet, between aircraft carriers, amphibious ships, and cruiser destroyers, you will see various forms of code and various what we call baselines. The nirvana is we get to one baseline, and that effort is called integrated combat systems. There's a business case that my colleagues have spoken to already on the ability to decouple hardware, software, and do updates much closer to real time, vice bring a ship into a yard, cut a hole in the side, and go in and install this new kit. So we are going to get to that point. The warfighting case for integrated combat systems is we have to get to a point where from our fleet commands to our strike groups to our unit level ships, they can pair any sensor to any shooter with any effect, and they can do that at machine speed. That's where we're going to have to be in a future fight to, one, effectively assign our both kinetic and non-kinetic effects, but it's absolutely critical that we commit to that. One final point, we've already deployed some what we call battle management aids, and these are programs that support the warfighter to make these decisions at closer to machine speed, and we have that deployed in about 4 of our ships right now. So we're in the early stages of deploying integrated combat systems, and that's moving along at a good pace.
So Matt, this discussion, and since we're at a software summit, one of the things that this raises is all these systems, that we're talking about, the ones on the ship and the combat system, as well as those on the adjunct vehicles, the large unmanned surface vessels, the UAVs, whatever else is operating with it, they're all different software programs built by different people for different purposes at different times. So are we looking at, when we say integrated combat system and what the DCO is doing in terms of trying to create solutions, are you looking at like federated, software, systems of systems or configuring software? Or are you looking at like, we're going to rewrite the software to make it so that these things are all part of some one kind of software system? Are we federating or are we unifying here?
Yes.
Okay.
It's a great question. I think partly it's how fast do we need to move, how fast do we want to move, and how willing are we as the Navy and the DoD willing to kind of walk away from sort of the gold-plated solution requirement. And I think the analogy is, hey, look, if we are looking to have some next 3 to 4 years, maybe we won't be able to achieve the nirvana of everything fully integrated in this single pane of glass. And I think we need to listen to the voice of the warfighter a little bit and say, hey, look, I can give you this thing that's 60% right now, and it's going to give you some level of warfighting capability, or we can wait 5 years and I can deliver the more gold-plated solution. Neither one of those is necessarily the right answer. It depends on what's the challenge and what's the problem we're trying to solve. But when it comes down to it, to what we were talking about with this idea of needing to leverage new entrant defense tech, hey, what's out there, dual use that we can sort of adopt as the Navy, we've got some challenges to overcome, certainly. A, how do we integrate those things onto the legacy systems? How do we train Navy users? How do we work with the companies to be able to make that bridge to having Navy adopt it? But also, if there's multiple of those systems in a system of systems approach, how are those individual systems communicating together? How are they sharing data? Who owns that data? And I don't think that's really a world that people inside DoD understand very well. I think software and AI is, I'm going to press the I believe button that there's a lot of people in the room who know way more about it than I do, and I believe you that AI is awesome. I don't know really how we're going to use it, but that's where we need to listen. We need to understand the concerns from industry of, hey, this is data that we invested an enormous amount of money into collecting, and it's proprietary, it's really important to us. And there's also some areas where the Navy's like, I understand that, but we need to be able to at least own this data or use this data or share this data with other companies in a way that potentially protects that proprietary data in a way that allows us to kind of knit these systems together. So if one system, as just for instance, unmanned systems coming in from different attack axes, using automatic target recognition, different grazing angles, different temperatures, they need to be able to identify those targets with similar confidence levels, and that we need to have confidence that those are sharing that same data set. So that's going to require some creative agreements with industry. We're going to have to work that out. But yeah, to your answer, I think it is a lot of work to be done, and I will be the first to admit that I do not think the Navy is the one that has the answer. I think we need to be a better partner with industry to do it, because long gone are the days where DoD is leading the charge on innovation. We need to learn how to fast follow much better.
And Matt, you bring up a good point about, people often throw out this idea that I need the 80% solution or the 60% solution, but they don't really define what the 40% that they're losing is. What is
Right.
that? What's the thing that's left on the table in that case? The way I hear you describing it is, it's the seamless integration that we're kind of used to experiencing in the military. So the weapon system, the weapon is probably just as lethal, as it would have been otherwise. But what you're losing, that 40% you're not getting in the solution you're describing, is that seamless integration. It's probably a laptop that's tied into something else, and you kind of have to do a little bit of sneakerware to move things between different elements of the system of systems. But it works, and it's becoming more integrated. Is that what you're getting at?
Yeah, that's exactly right. It's just that ability. I think we're used to. Hey, it should. In an ideal world, single pane of glass, every system I have, I can see their sensor data, it's all knitted together, and when I make a decision, it's just one control station, communicating. And that's sort of, I think, the vision with ICS, is to pull all those systems together. Right. And that's great, and that's an ideal world. But if I could have essentially that system, and I got 2 or 3 laptops outside of it where I got, Seaman Timmy and Seaman Johnny on the laptops, and they say, hey, look, I can hit the button here and shoot this thing, or I can hit this button and leverage this autonomous piece of hardware. Less than an ideal case, that single pane of glass, but certainly much more functional than not having that capability in the first place.
Right. Right. So Bruno, when we talk about software, integration like this, as we said, there's not a lot of expertise inside the department when it comes to acquiring software, understanding, how do you integrate different software packages, understanding the limitations that come from a lot of the existing software systems that were developed by companies that primarily build hardware and then build software to sort of make the hardware work, but it's not really the best software. How can we use it? Can the department bring in software companies to do this integration function, and it's explicitly their job as we build a software ecosystem? We don't have a dog in the hardware fight.
Absolutely. I think it has to be done right, which is no small thing. Right. I think it involves a lot of iteration, but I think the problem, that Matt's kind of like exacerbating here, is that variability eats up your efficiency. So that's true for data, that's true for the different software systems. If you have a bunch of things that are different shapes, different colors, it eats from your efficiency. So how do you solve that problem? You need standardization of processes. You need unified ecosystems that can get data from different sources and serve different applications, whether it's repair and maintenance or whether it's something more tactical on the field. So I think that creating that, bringing that expertise from industry, but it's a partnership, right? Like industry is evolving, the Navy is also evolving, right? Like, so bringing that partnership in and changing the model so that we can create those standards is extremely important. And that variability, that evolution goes deeper, right? We're talking about conditions-based maintenance instead of time-based maintenance, right? Like, and I think that the next frigate program will be that way. We're gonna have sensors on the, which is fantastic. However, you need to be able to retrofit because technology keeps evolving. And how do you do that? How do you do that when you get a new line of ships on the ocean and they're meant to be there, they're meant to be operational for what, 20 years, 30 years, but technology is going to keep evolving. China is going to keep evolving their technology. So how do we do that? How do we retrofit? How do we bring in new technology to the ships we have?
So Bruno, to what degree can you automate that process of data engineering, right? So today, what we would have to do is have a bunch of young programmers sit down or data scientists and figure out, okay, what do I need to do to clean up this data to make it useful for this other system because we don't have unified standards across the board. Are there ways to automate that? And when you say standards, do we mean standardized, like here's the format for all the data, or do we mean standardized interfaces between different elements of the software ecosystem?
Both things, but I think it kind of like beckons a little bit back to what I was talking about, where the data science discipline has been, and look, I've been there myself, I've been the guy behind the keyboard many times, have been a lot of like, let's try to create value from bad data.
Right.
And that's good. It's like you should do this. But now we are in a point where it's like, hey, what if we created awesome data instead? Right? Like, what if we develop the mechanisms that give us the data that solves the problem, that has the purpose we're looking for? So, sorry if I'm going back to this, but I think that is the crucial point. It's like, what are we looking for here? What are we trying to do? I need to know how rust develops in a flight deck. I need to know about metal thickness in a hull over time. So I then can develop the system that will scan for that and provide that data so that data science doesn't become high-tech tea leaf, really. So yeah.
And so there's an analogy here between what you're talking about, which is maintenance, management, and planning, and also warfighting operations, which is something that Matt was focused on. Is you've got data that you've got to collect in advance to help build an AI model that's going to predict how something might perform in combat. So it's helping you in your capability, concept development process. And then you also have to gather data in situ when the actual operation is happening, so you can help do course of action development and help commanders decide how to employ their forces. So would you use similar systems to do that? I mean, you guys build systems that gather data in both situations, right? Both to kind of build the model of how does Rust develop, and then also go in and see, well, actually what is going on with this particular ship. Is that the case?
Yeah, there are lots of synergies in the process. Obviously, your technology stack will have variations to it, and we're dealing with this now. Like, we have traditionally focused on these magnetic crawlers that are very well suited for hulls. But if I'm looking at something of a slightly different geometry, I might need a drone. I might need a different way to move the sensor, or I might need different sensors. So as I'm working with the Air Force for the silos, we're talking about concrete. So we have developed concrete sensing technologies for that. But ultimately, the shape of the process is very similar, whether that data is operational or not. We are we're piloting a bunch of things around operational data in industry right now, and we're hoping to bring that to the DoD as well.
Go ahead.
Could I follow up?
Yeah.
So we discussed this, DoD, Navy as a customer
Right.
in this software development. And I think one example where I believe we've got it right, and I welcome pushback on this, is the work we're doing with PEOIWS, so Program Executive Office, Integrated Warfare Systems, and the Software Factory. So this applies to what we're doing on battle management aids. This applies to what we're doing with Integrated Combat Systems. And Seiko Okano brings in all comers. If you believe you can solve the issue that we have, then I think there's a pretty low barrier of entry of getting into that software factory to provide a solution. So I think that's one example of what right looks like as we work this problem.
No, definitely. And so one challenge of the software factory is, how do I take those decision aids that I'm building in the software factory and make it so that they can work inside the Aegis combat system? So does that end up being like a standalone computer off to the side? I use it for course of action development, which could work. Or am I actually able to use the real-time sensor data from whatever the Aegis combat system is taking in, and then can I use it to actually drive the systems on the ship or even off the ship to act? Or am I having to do that separately? Like, to Matt's point, am I doing this as a set of people working together, aided by AI and decision aids, or is the decision aid allow me to kind of direct this action automatically?
Yeah. So we have opportunities to leverage real-world data, given what the team is doing in the Red Sea right now.
Right.
We have reach-back capability to take that information, analyze it, and if there's things we need to improve on tactics, techniques, and procedures, we can push that back out.
Right.
We also, Software Factory can also leverage our land-based sites,
Right.
Like we have at Moorestown or in Wallops Island, so it can be, we can reduce risk that whatever they're going to deploy onto a float platform has at least been tested on a like system ashore.
Right, right. But and they can make it so that system can be to some degree integrated with what the Aegis combat system's doing.
Yep.
So Matt, in terms of what the DCO is doing, how do you obtain that kind of real world data like Bruno's talking about to help guide solution development in support of what some fleet commander needs to solve a problem? And then how are you then evaluating the potential solutions in the prototype, I guess, environment?
So the first thing we're doing is, I think we're getting better at fleet experimentation that partners with industry. So it started several years ago with Task Force 59 out in 5th Fleet in the Middle East. And that really just started with, going back to the idea of an operational problem of, hey, we suddenly are in an economy of force theater. We don't have the assets out here anymore that we used to. And yet we still have this vast water space that we need to maintain maritime domain awareness over. How do we do this in a non-traditional way? And so that led to the creation of Task Force 59, where they partnered with industry. They brought in autonomy, started working with data and networks to see if we could use AI to make sense of it, and did a lot of great learning and really closed a lot of that maritime domain awareness gap that they had. We've scaled that from 5th Fleet now into 4th Fleet. We actually started to operationalize some of the systems proved out at Task Force 59 down into 4th Fleet. Off of South America, and using that to combat Chinese distant water illegal fishing, combat counter drugs, counter trafficking, but using those unmanned systems to prove out that you can use those things at an operational level. And so I think the answer is you create systems and sandboxes where the Navy can partner with industry, and we can put those things in the hands of warfighters and iterate and learn and get better and better and learn how these things actually work in a real-world scenario. And I think that friction helps us generate, hey, what works, what doesn't, and what are ways we can use these things in new and innovative ways that we have not thought about before.
Right. And you could see applying those same techniques to, like operational problems facing, commanders today, like, how do we address an invasion of Taiwan by China? We just heard in the previous panel discussion about, how that is a near-term, challenge that the DoD faces. Obviously, you could take some of these systems and some of these same techniques and apply it to that problem set.
Absolutely. Yeah.
As we wrap up, because the little timer thing is telling me that we're running out of time now, I wanted to ask one more question, kind of to look forward here a little bit in the near term. So obviously the Navy's very busy right now around the world. Matt talked a little bit about how we're using data to help us guide operations in the South China Sea and dealing with some of the gray zone warfare that's being done by China. How are we taking advantage of the data that's coming out of the Red Sea now, beyond just using it to help improve our decision aids? Are we able to use that to figure out how to make the fleet more lethal into the future, make some of these decisions you're talking about in terms of equipping the next generation of ships or the current generation of ships?
We are, Bryan. So 10 years ago, the Navy invested in warfare tactic instructors. We took a page from our aviation teammates. This dates back to when the aviators stood it up post-Vietnam. Those WTIs are proliferated throughout the fleet. They're on the ships that are firing right now. But as I alluded to earlier, I think the most important piece of that is we have reached back to our Surface and Mine Warfare Development Center, SMIDC, that manages this for the entire fleet. So we are leveraging that tactical data to make sure that we take the lessons learned, we feed that back to the ships that are in theater to make sure they have the most current tactics. And then at the same time, we're feeding it to the next deployers. So as they work up and they certify, they have that information as well. There's less sexy work like the logistics in the theater. Yeah. Typically, the South Red Sea and the Bab el-Mandeb is a place we pass through. So there's logistic work that we're learning in that theater that we're also taking lessons on to make sure we apply to follow on presence there.
And since I'm just going to run long anyway, so Matt, is the DCO also looking at what's happening in the Red Sea to evaluate alternative solutions to deal with the challenge posed by something like the Houthi terrorists? Because keeping a few destroyers down there is maybe not something that the Navy should try or would want to do over the long term.
Absolutely. I think you can look at what's happening in the real world from the Red Sea to what you're seeing in Ukraine, and there's all kinds of areas we see, not only operational problems that have yet to be solved, but areas where people are using technology in incredibly creative ways against legacy forces. And so we can't ignore, I think, really any of those lessons. And so all of those are kind of inputs to the DCO. And really broadly what it is, it's still a small office. The mandate is essentially several game-changing technologies per year that we're trying to really push through. And again, starting back with the number one problem is, hey, what are the key operational problems according to the fleets that we need to solve? And starting with that, as opposed to, hey, what are all these different opportunities that we can kind of mismatch to problems? So it's again, problem focused first. And so, but certainly what we're seeing out there in the real world is informing us.
And Bruno, you're going to get a whole bunch of new data as all these ships that have been extended on their deployments are going to need much more work. So, are you guys thinking? Are you able to use the tools that you have to start thinking ahead about what's the need those ships are going to have for maintenance beyond what was already planned in their maintenance package?
Absolutely. Like what we are building is meant to be very future-proof. It's meant to be to tackle different kinds of ships, different kinds of assets. We're moving into shipyard assets as well on the construction side. So yes, the idea is to be future-proof, and we are present in the Middle East. We have offices in the region. And
Wow. Okay. Great. Well, thank you very much. I really appreciate you all taking the time today to have this conversation, and thank you all for being here. So if we can give a great big hand to our panelists.
Thanks, Bryan.
Admiral Fred Pyle, Captain Matt Culp, and Bruno Rocha from Gecko Robotics. Thank you all.